Welcome everyone. This is our 41st live stream geometry. So if you'd like to join future sessions, feel free to email me at mgreenb801.com. They're at 9 a.m. US Central Time. So we have 3 people here with us right now. And today I'm going to be going through a mock contest called GGG. So it's created by someone named Andrew Wu, who's posted on my channel before. He's done fairly well in math competitions and Olympiads in the US. And I think he's created 4 of these contests. So I'm going to be going through the 6 problems from the first 2 of the contests. And so with that, I will get started. So let me share my screen. All right, so sorry about that. Here's the first problem I was going to go through. So we have a triangle ABC with incircle omega. All right, my GeoGebra is a little slow right now, but I think it'll speed up in a little bit. So we want to draw the incircle and the circumcircle. Whoops, I don't need to do that, but let's draw the incircle. And why not also the incenter? Okay. And it touches each of the sides at D, E, and F. And H is the foot of the altitude from A. So I'm just going to draw a point. I know I also have to draw this MA. I'm going to draw it in a second. So this point is H. So I can delete G now. And I'm going to draw MA. So that's the midpoint of arc BAC. Oh, it's the minor arc BC, sorry. So I just need to see where does AI meet the circle. And that will be point MA. Let me hide the, there we go. We want L to be the intersection of MAB and AH. I'll make sure point D shows up. There we go. Oh, so maybe I should have drawn, well, no, I only need to draw that for the altitude. Okay, so we want to see where does MAB meet AH? We call it L. And IE and IF are the X centers of ELF. All right, so we just have Feng joining us right now. I can close this. Okay, so we have triangle ELF. We want to show that the E and F X centers lie on the incircle. And of course, we only need to show it for one, because then by symmetry, it would be true for the other also. Interesting. So let's check that it's true. Maybe what I could do is I could take the angle bisector of FEL and I could let it meet the end circle. And then I could try to show that that is the X center. I think that might be a good way to do it, right? So for example, if I draw the angle bisector of EFL and I let it meet the end circle at a point G, then we want to show that G is the X center. I wonder if AH is the angle bisector of FEL. Let's actually check this out. So it doesn't, that's weird. It doesn't look like G is the X center because GE, oh no, the X center, we would want the midpoint. Okay, so basically, I'm just guessing that this might be the end center right here. I'm not sure yet. If that's true, then the problem is saying that if we take the midpoint of these two, then it's saying K would be the circumcenter of JE. Ah, looks like it's true. Okay. So, interesting. So first of all, can we show that J is the end center? So can we show that AH bisects angle FLE? There's a lot of interesting stuff going on here. So the end circle and the circumcircle are like homothetic. So if we take MA and D, I wonder if L is the point of homothety of the two circles? I think it might be, right? I guess what we could do to check that let's see, if that were true, then MD would be parallel to AMA. Is that true? So AI and MA are collinear. Oh, and it looks like those concur maybe on, so yeah, it definitely looks like L is the center of homothety of the two circles. And if that's true, I wonder if it's not that hard to show that AH is the angle bisector of FLE. Yeah, this is an interesting configuration. Let's see. Sorry, I don't know if you guys can hear it. There's like a little dripping noise outside. So yeah, if you hear that, sorry about that. Let's see. So, I mean, AI is perpendicular to EF. So can we show MD is perpendicular to EF? Then that would prove that L is the center of homothency, right? Well, yeah. Is that obvious? I feel like I'm missing something obvious here. So yeah, I mean, I guess it's is it really true that MD is parallel to AI? It looks true, but if oh, maybe it's not true. Maybe I just got confused. Let's see. Yeah, I'm starting to wonder if they actually really are parallel. No, they're not parallel, right? That doesn't look parallel at all. So if that's true, then I was wrong. That's not really the center of homothency. Yeah. It was just an illusion. It looked very close, but it's not true. I'm going to just erase MD then. So yeah, I don't think L is the center of homothency of the two circles. But I think MAD passes through the Sharkey double point. So maybe it's worth drawing that. Interesting. Okay, so MAD, I've proven this in my video on Sharkey double. So MAD is going to pass through L, and it's also going to pass through this point, N. So yeah, this line passes through all these points. LI is parallel to BC. Looks like I accidentally hid point C. And then we could let K be the other intersection. Sorry. Okay, so basically I drew the angle bisector of EFL. I let it meet AH at J. And I wanted to show that J is the incenter of FLE. Let's see. Are L, I, and G collinear? That's a good question. Let's see. Looks like it. Yeah, interesting. So yeah, it looks like L, I, and G are collinear. So basically, we want to show the angle bisector. If we draw this angle bisector and we let it meet the incircle at a point in G, so I'm going to delete this circle for now. We want to show that I mean, we want to show that circle exists and that K is the center of it. So yeah, I mean, it would have to be true if the problem were true, right? Because if G is the X center and K is the N center, then angle JLG is 90 degrees. So yeah, it would have to be true. Yeah, that might be a better way to do it. So yeah, I agree. But yeah, I'm trying to show that J is the in-center. So let's see, can we use the in-center, X-center lemma? Because if okay, so first of all, arcs AF and AE on this circle are equal, right? So that proves that this is actually an angle bisector, right? And so that means that J is the in-center. So we know J is the in-center. Let me delete K for a second. So yeah, can we show F? Can we show that Fj and Li concur?
Michael. So I have maybe a solution. So we will call Li cut the in center at 2 points.
Cut the in circle at 2 different points?
Yeah, and it could be G and K maybe.
Okay, K on this side?
Yeah.
Okay, hold on just a second. All right. All right.
Okay, so let LF cut the in circle at another point. Yeah.
Okay.
Yeah.
Hold on just a second.
LF. Yeah. Okay.
LF. All right.
Okay. So we will have that angle ELG is equal to angle GLO.
ELG is GLO.
Yeah, because ELG is a half of arc EI, and GLO is the ELO. Yeah. So two angle is equal. So G is the midpoint of the arc EO, right? So yeah, FG will be the angle bisector.
So G lies on the angle bisector of EFO because it's the midpoint of RPO, and it also lies on the angle bisector of ELO. So yeah. All right.
Yes. So we will have FG and EK is a two angle bisector. Yeah.
All right.
And yeah, but IL is the diameter. So angle JEG is 90 degree. Yeah. So G will be the X center.
X center. So I think, but I think we can. So the angle bisector of EF. So G, it lies on the angle bisector of EFO because these two arcs are equal, right?
Yeah. Yes.
And then it also lies on the angle bisector of ELO, right?
No. We have to let EL cut at another point.
Oh, we have to let EL or.
Yeah. Yes. So K will be the midpoint of that arc. Yeah. So K will be the midpoint of the F and the new point.
But I wonder if the problem's easier than that, because let me think. So you're saying to draw this point right here, right?
Yeah. G is the midpoint of arc EO and K is the midpoint of arc FP.
Mm-hmm.
Yeah.
So since G is the midpoint of arc EO,
so EG is FG is the angle bisector of angle EFL. Yeah, and the same with K.
so hold on just a second. So L is L the midpoint of M is so is KG a diameter?
Yeah, KG is the diameter.
Okay.
Yeah. So G is perpendicular to EG.
But I think it's simpler than that, because yeah, so G is on the bisector of both. Sorry, but basically, so LA, we can show it's the angle bisector of FLE, right? Because arc AF is arc AE. So LA is the angle bisector of FLE, right?
Yes.
And so since angle ALG is 90, that means that LG has to be the bisector of ELO, right?
Yeah.
And so we know LG is an angle bisector. But how do we know FG is an angle bisector?
Yeah. So we don't need the point G.
We don't need point G?
Yeah, we will call G as we will define G as FG cut EK. We don't need the point J. We don't need point J.
Yeah.
Yeah, we will define J as FG cut EK. After. Yeah.
So
yeah, we will prove G is the midpoint of arc EO first. The same with K.
G is the midpoint of arc EO.
Yeah.
Okay. So and you prove that because you say, how did you show that G is the midpoint of arc EO?
Oh, that is because angle ELI is equal to angle OLI.
Okay.
Yeah.
Because ELI, how do we know? So ELI is EAI is, I guess, how do we know ELI is OLI?
Because OLI is 180 minus FLI, and that is FEI. But
Oh, actually,
FEI,
okay. So
yeah.
so I see that ELI is OLI. How does that prove that EG equals GO? The arcs are the same.
So we will okay.
Let's see. So yeah, I see that ELI is OLI. Maybe it's just an angle chase because OLI is 90 minus OLH, which is 90 minus FLA, which is 90 minus ELA. Yeah, so I think that solves it, right? Yeah.
But we have to.
Oh, but how do we show the arcs are equal? Yeah, not just the angles. Yeah.
This because we have to prove that EO is perpendicular to IL because FOE is equal to 1/2 of arc EF. Yes, and angle FLA is 1/2 of arc FLE, and arc FLE is arc FIE. Yeah. So AL will parallel to EO.
Okay, so I see Jaleel just posted in the chat. So yeah, I see how ELI is equal to ILO. So yeah, so now I'm going to do what Feng said. So basically, you want to show that EO is perpendicular to IL, right? That's what you're trying to do. And you did it using arcs. So basically, you would look at angle FOE.
Yeah.
And
FLA.
So FLA. So FOE is twice FIE, which is twice, which is
1/2. Yeah.
But how does that tell us about G? I guess I'm a little confused.
Because I is lie on the bisector perpendicular of EO, and LI is perpendicular to EO. So L will lie on perpendicular of EO.
Okay, because we know I lies on the perpendicular bisector of EO. I think that's the key.
But could we prove that IL is perpendicular to AH?
Oh, yeah. So I proved that in another video that IL is perpendicular to AH. I think it's so. It's like the same as saying angle ILD is angle LDH. And I think that's just an angle chase because ILD equals NAMA, which is equal to NMA and the angle that NMA makes with this tangent line. So yeah. So yeah, hold on one second. So okay, so basically what Feng said is I lies on the perpendicular bisector of EO, and also angle EIG is angle OIG. So G has to be the midpoint of arc EO. I think that's the idea. Yeah. All right. Does that make sense? I think that makes sense. Yeah, because angle EIG is angle OIG, and IE is equal to IO, so that has to be a kite, right? So I think that just solves it. Okay. All right, I'm going to type it up and then move on to the next problem. So whoops, let me move this to the side a little bit. So first I'll define L. Let L be the perpendicular from the foot of the perpendicular from I to AH. All right. And then by the video on the Sharky Devil configuration, MA, D, and L are collinear. And it's, I'll say, or an easy angle chase. MAD and L are collinear. And then once we know that, so F, L, I, E, and A are six. So I'll just write it like this. So angle ILA equals angle IFA equals angle IEA equals 90. So that means ILFAE is cyclic. And then we also know that angle FIA equals angle EIA. So I'll just say arc FA equals arc EA. So and that implies that LA bisects FLE. And once we know that, since ALI is 90, that means LI bisects ELO. I'll just say let FL meet the incirclet O. So all right. And then since ALI is 90, LI bisects ELO. And also, since IE equals IO, that means that I guess if LI bisects ELO, and also I lies on the perpendicular bisector of EO. Let's think about this. So since I lies on the perpendicular bisector of EO, I don't think I'm leaving out anything here, but let me know if I am. So that has to mean that LE, so that means that LEGO is a kite. Is that right? . Do these two things together mean that LEGO is a kite? I think so. Because let's see, IE equals IO, and angle ELI is angle OLI. Yeah, I guess trying to prove it. Yeah, do these two things imply LEGO is a kite? Oh, because yeah, by side angle side, LIE is congruent to LIO. So yeah. Oh, but how do we know GI? I'm getting confused again. I think this is enough. I'm gonna move on, but I think these two things. So I think imply LEGO has to be a kite. So that means that so G lies on the bisectors of EFL and ELO. G equals IF lies on omega, and then similarly IE lies on omega. All right, I'm going to move on to the next one. All right. All right, thanks everyone. So here's the next problem. Whoops, didn't mean to erase that. So we have an acute triangle ABC. And D, E, and F are the theta altitudes. And we want to see where EF meets the circumcircle of ABC. So let's draw the circumcircle. Let's draw the altitudes, D, E, and F. We make this a little smaller of a circle. That looks better. D, whoops. D, E, and F. EF beats the circumcircle at 2 points. And I feel like I've seen this idea before. So A is going to be the midpoint of S1, S2. And that's not a hard angle chase. So A is the midpoint of S1, S2. And P is the intersection of BE and, okay, so basically we draw these two. And this is the orthocenter. This we'll call P. And this one is Q. we want to show the circumcircles of DSS1 and DPQ are tangent. And they're going to be tangent at point D, of course. So let's hide some stuff. I like this. This isn't a super complicated configuration. Whoops, I don't want to do that. So we do that and that. Whoops. DSS1. So I wonder if DH bisects this angle. Let me check it. No. But I know there's a circle centered at A.
The S1, S2 passes through the midpoint of BC.
S1, S2 passes through the midpoint of
The circle of the S1, S2.
Okay. Hold on one sec. Right, we have another person just centered. So it passes through the midpoint right here. Yeah, I think I've seen that before, but because A is the midpoint of this arc and G, I don't remember why, but
If you intersect EF and BC, then we can prove it from power of point and harmonics.
All right. I think I did that in a previous video, so that's how we end up proving that. Okay. So for now, I'll just take it as true. So, okay, so should we let DF and DE meet this circle? Let's see. I guess the easiest way to show two circles are tangent is to like I could let DP and DQ meet this circle at 2 points and then show that that's parallel to PQ. That's probably the easiest way, right? I'm gonna try that. We just have to show.
I guess S1, S2, PQ, and BC are concurrent.
PQ and BC. Okay. Hold on a sec. So I'm going to draw those. Is that by the radical axis theorem?
If you take take triangle DF as the main triangle, it's easy to see. It's a well-known thing.
Okay. Because K is the point that's in harmonic conjugation with D. So Yeah, because I guess by Bricard's theorem, KP is the polar of A with respect to this circle, and KQ is the polar of A with respect to this circle. And yeah, I guess you could try to show those two polars are the same because, and I think they have to be the same because AF times AB is AH times AB is AE times AC. P and Q are the theta angle bisectors. So H is basically the incenter of DEF. Okay. All right. Yeah. Interesting. But that makes sense. Can I draw the circle? Yes. Oh, DPQ. Yeah, it looks like they concur here, right?
Can you intersect it with DS2?
With ES2.
DS2.
Sorry, one second. So intersect what with ES? Oh, DS2. Sorry. My bad. I thought you said ES2. That's why I got confused.
Can you let PQ and GS2 meet?
Yeah, PQ and GS2. Oops.
I think they concur on AC.
Which two? Say it one more time. Sorry.
PQ and PQ.
PQ. Oh, AC.
They are not concurrent. Okay.
Yeah, it's very close though. But yeah.
It seems like true for left. No, it's not. Okay.
Oh, these are not concurrent here. Yeah, it looked like it, but yeah, I'm not sure how to draw it so that they don't look concurrent. I guess that's all
You
right.
can delete these. I think they are useless.
Delete L.
Yeah.
Okay. So we want to show IJ is parallel to PQ. That's one way to solve the problem. So you could try to show angle PQD is angle IJD. So if H is the incenter of DEF, and PQ are the theta angle bisectors, I wonder if we could try to make like I and J something similar.
What is the incenter of triangle DIJ?
EIJ or oh DIJ? Yeah. Let's see. So it's that point L. Oh, but A is the midpoint of arc S1, S2. So maybe we could use that somehow. All right, I'm gonna delete L just for now. Hold on one sec, be right back. All right. Okay.
Michael.
Mm-hmm.
I have a solution, but it kind of a little bit complicated.
Okay.
So we have a lemma that if we call JKL, L is the center of the 9-point circle.
Okay.
So IL will perpendicular to PQ.
Okay.
Okay.
All right.
All right. That is because P and Q have the same power to the 9-point circle, and the circle HBC PH times BB is PF times BD, and Q is QE times QD is equal to QH times QC.
Okay. So the line connecting A to the 9-point center is perpendicular to PQ.
Yeah. So could you write?
Yeah.
Yeah.
Hold on one sec. So I think a 9-point center is number 4 here. So I'll say let.
Michael, we will need the circle of ABC too. The center of circle 70. So yeah, ABC too.
Oh, it's 5. Okay. So whoops, I gotta go up. So let me change that. Sorry. So N, I should change this to 5 instead of 4. And then I'll draw the I'll call this point O.
Yeah.
Oh wait, where is it? There we go. So this is O. So we have AN is perpendicular to PQ.
Yeah.
And because P and Q have the same power with respect to the 9-point circle. Okay.
Okay. So this is my idea. Yeah. So the center of the circumcircle of DS1 and S2 is the intersection of the and the bisector perpendicular bisector of DG.
So say that one more time. The circumcircle of what? GS1?
No. The perpendicular bisector.
Okay, hold on one second.
Yeah, of DG. Yes. And yeah, and the line AO.
An
Because
AO.
AO is the no line not yeah, line AO, just AO, not the perpendicular bisector.
Okay, hold on.
Just AO. Yeah, the intersection will be the center of the circle.
Okay, because
AO
is perpendicular to S1, S2. Yeah, AO is like the perpendicular bisector of it. Yeah.
Yeah, and if we call DA, cut the circle at point at another point.
BA?
DA. DA. Yeah.
Okay.
Okay. So yeah, cut at the point. So LM will be LM will be perpendicular to IJ. Because M is the middle of a point IJ, the arc IJ.
All right.
Yeah, so we have to prove that AN is parallel to LM.
Oh, so I think we proved it because or wait. So we want to show AN is parallel to LM. Okay. Yeah. All right.
Okay, so we okay. So hold on.
Sorry.
So we need to prove that AN is parallel to LM. So and AM is obviously parallel to LN, right?
Yeah.
And so we need LN is equal to AM.
Mm-hmm.
Yeah, but could you draw OH?
Yes.
Yes.
So N is the midpoint of OH, right?
Yeah, and so L will be the midpoint of OA.
Okay.
Yeah, and so on LN will be a half of AH.
Okay.
Yeah, that will be a half of AH is OG.
Mm-hmm.
Yeah. So yeah. Because angle MDG is 90 degree, so GM is the diameter. So L will be the midpoint of GM.
Interesting.
But L is the midpoint of AO. So MAGO will be the I don't remember what
parallelogram.
Parallelogram. Yeah. So we complete the our proof.
All right, I like this. So I think we did we need point K for this proof? I don't think so, right?
Yeah, we don't need point K.
Okay. Interesting. All right, so let me hide a couple things. So first, I'm just going to assume the fact about that 9-point center, and then I might get back to it later. Okay, so all right, let me start typing up some stuff. So let me close this. Oops. So yeah, oh, we did use that this circle passed through G, right? So I think we should draw point K because we kind of use that.
Yeah, we will have to use that.
Did we use that K, P, and Q? I don't think we used that. So I'm just gonna, but yeah, I agree. It's not hard to prove. Okay, so let S1, S2 meet BC at K. And let the circle DS1, S2 meet BC at G. And then I think it's by power of a point, you can show G as the midpoint, either that or some harmonics. Okay, so if we can show that, so K, B, D, and C are in harmonic conjugation. So we wanted to show that AM, LN was a parallelogram. So LN is half of AH, because L is the midpoint of AO, N is the midpoint of HO. So yeah, but so trying to remember how we should.
Half of AH equals to OG equals to MA. Okay.
Exactly, and OG has to equal MA because angle MBG is 90, so MG passes through L. So yeah, that's how we did it. But yeah, first I'm trying to remember. So we have how do we know that this circle passes through the midpoint of BC? So you said it earlier, Sridhar.
From harmonic, we know that KB multiplied by Kc equals to Kd multiplied by Kg.
Yeah, so that's how we did it. So so we have Kd times Kg is Ks1 times Ks2. Which is Kb times Kc. And so since K, B, D, and C are in harmonic conjugation, so that means that G is the midpoint of BC.
How did we prove that ALO are collinear?
So Feng was saying that it's a well-known fact that I'm sorry, go on.
No. Yeah. So we define L at the center of circumcircle of the S1 S2, right?
Yeah.
Yeah. So L will lie on the perpendicular bisector of DG.
Yeah.
Yeah, and L will lie on AO too, because AO is the perpendicular bisector of S1 S2. But yeah, but LN is perpendicular to is parallel to AH, and N is the midpoint of OH, so L will be the midpoint of OA.
Yeah. So I guess we're using so AO is perpendicular to EF. That's well known, and then yeah, and then that AS1 equals AS2. I proved it. So I know everything on my channel. Like I've done so much on my channel, it's hard to remember. But basically, yeah, but I don't think I don't think those two facts are enough to prove that AS1 equals AS2. Like you could know that OS1 equals OS2, and oh, maybe that is enough actually. Yeah, that is enough. You're right. So yeah, so it's well known that AO is perpendicular to EF, and so AO has to be the perpendicular bisector of S1, S2. Yeah. All right. And so that means that A, L, and O are collinear.
We have to define L as the center.
Yeah, so you have to define L. So let L be the circumcenter of DS1, S2. All right. Oops. And then L lies on the perpendicular bisector of BG. So AL is equal to LO. All right. And also, Hn equals NO, that's well known. So that means that ln is half of AH, which is OG. And then once we know that, and then also ML and G are collinear. So I'll say angle MDG equals 90 implies MG is the diameter and passes through L. So all right. So then that means that M so here we had ln is equal to OG. Maybe I'll switch these two. So this one I'll move down there, and this one I'll move up here. So ln is half AH is OG is AM. So that means that LM is parallel to AN. And but Feng was saying it's well known that AN is perpendicular to PQ. So I'll just write that out for now. So maybe I'll put a star by it. And we also know that M is the midpoint of arc IJ. So yeah, we're trying to show IJ is parallel to PQ. So we have LM is perpendicular to PQ. We also know LM is perpendicular to IJ because we know M is the midpoint of IJ. So let me make some room here. How is PQ perpendicular to AN? So yeah, that was a power of a point. So yeah, that's why I put the asterisk right here. So I'm gonna explain that a little more in the end. So hold on just a second. LM is perpendicular to PQ. And M is the midpoint of arc. So I'll say DA bisects angle FDE. So that's Blanchett's theorem. Or easy angle chase. And that implies M is the midpoint of arc IJ. So that means LM is perpendicular to IJ, implies IJ is parallel to PQ. So we have and that implies by a homothety at P, or homophoty at D, the circles are tangent. D, S1, S2, and DPQ are tangent. So now I'm going to explain what Hakan was asking. Let's see if this all fits. All right. So we want to show how do we know PQ is perpendicular to AN? So basically, Feng, I think, was saying that they have the same power. So DFEG is the 9-point circle. So the power of P with respect to that is FP times FD, which is the same as PH times PB. And the power of Q with respect to the 9-point circle is QE times QD, which is QH times QC, right? And oh wait, no, they don't have the same power. So wait, Feng, can you mention again how you prove that PQ is perpendicular to AN?
Oh yes, PF times BD is equal to PH times PB. Yeah, so P have the same power to point to the circle 9-point circle and circumcircle of HBC.
Oh, HBC. Okay.
Yeah.
So
and,
they lie on the radical axis of those two circles.
Because hold on.
Sorry.
Okay. So if we call the if you call the center of HBC. Hakan is saying what I'm saying. We have to draw the circumcircle of HBC and the center too. Could you draw it?
Yeah. So the circumcircle of HBC, that's like the reflection of the circumcircle of ABC.
Yeah, of OBC. Yeah.
Yeah. So do you want me to draw I'll draw the center of that circle. R.
Yeah. So we need to prove that A and R is collinear.
Yeah.
Right. Yeah. And that is because yeah, as Hakan saying, it is the homotopy at A with the ratio 2.
Yeah, because if you reflect O over BC, you get R.
Yeah.
Right.
Yeah. And OR is equal to AH. So AH and RO is the parallelogram. Yeah. So A and R is collinear.
Okay. I'll just write that really quickly. So let R be the center of the circle HC then OR equals AH. So that means that AHRO is a parallelogram. And then that means that A N and R are collinear. And that means that PQ. So first I'll write that, and then since PF times PV, so P has the same power with respect to both circles. So that means that PQ is perpendicular to AN. All right, very nice. So I will move on to the next problem. Actually, let me just space this out a little bit. There we go. Where's the typo? OH, oh yeah, you're right. OR equals AH. Good call. This is a nice one. So